Hello everybody, Mr. Tilley here. We're continuing to examine the soil data we collected from the school forest. Today I want to talk about the parent material we find in and around our school forest. Remember, think of parent material as the starting point for our soils, that starting material. Let's start with the image we have in front of us. This shows the approximate extent of the last glacial advance and how far it went across North America. The Great Lakes are present for reference, which gives us an idea of where Verona is located. So Great Lakes are here, Verona is located somewhere right about there. Notice that the glaciers covered most of the northern part of the United States. What's of interest to us is what the glaciers left behind. You can see here a series of slides which shows the retreat or the melting of the glaciers. Notice that by about 7,000 years ago, the glaciers had completely melted from Wisconsin. About 20,000 years ago, they would have still covered Verona and then started to retreat sometime after that. Geologically speaking, this is a very, very short time ago. It does give us a time frame then for about how long our soils have been developing. Here's a close-up of Wisconsin with Dane County outlined in red and Verona marked with an X. Notice that our city lies right on the edge of the glacial advance. This is actually very significant. It means that just to the south of us, we're going to see very different landscapes and soils. Also notice that the southwest corner of the state was not covered by the most recent glacial advance. Pretty much this entire area outlined here in red. So you can see from this picture, the landforms of Wisconsin do vary according to whether or not the land was covered by glaciers. And if so, the position of those glaciers. We're going to talk more specifically about glacial landforms in a slightly different unit. But a couple things just to notice. Number one, notice this driftless area that we outlined in the last slide. And notice how different the landscapes look like in this area. All of this. Those landscapes are mostly carved by erosion, small rivers, streams, wind, things like that. And then you can see the position of Verona, and once again we are located right on the sort of furthest extent of the glacial advance. So take a look at this slide. Try to imagine a wall of ice just like this outside our classroom and covering our school forest. Hard to imagine, but just as recently as 25,000 years ago, there would have been a wall of ice just like this covering Verona. So let's talk a little bit about what the glacier left behind. Notice in this picture of a modern glacier, the dark debris ahead of the glacier. When the glacier retreats, this debris is left behind. This debris is what's going to form the basis for our soils. This is our parent material right here. All of this debris, okay? Notice the glacier is not just solid ice. Within the glacier, you have all kinds of debris that is incorporated. When that glacier melts, that debris, of course, is left behind. So very commonly, extending from the glacier, you will have streams. So as the glacier is melting, glacier is retreating, you'll have streams that carry meltwater from the glacier. Sometimes these will puddle into lakes. These streams will carry sediment away from the glaciers. That the streams have an ability to sort material into various sizes. You can see a little pen here for reference. Again, this is a modern glacier. And the particle sizes differ. Small particle sizes, small as silt, all the way up to giant boulders. So if we take a look at this little slide, this is a cutaway of a landscape that exposes the soil and the underlying glacial material. Notice at the top, you do have a nice mix of organics and minerals. A nice A layers present on the tippy top. You can see a nice dark soil. Underneath we have a B layer. And then below that you can see some weathered sea horizon. That would be this area right around in here. Okay. where you have a mixing of the glacial material, you have some weathering that is apparent, and then below that you have the unweathered glacial material. And in this case, notice that there is quite a variety of particle sizes, really big boulders all the way to very fine particles, really a very distinct mixture. Also notice, based on the relative size of this individual here, this glacial material can be, several feet thick. So this is a case of some glacial material that was dropped that is not well sorted. Of course, you can also have examples like we mentioned before. If you have a stream that is carrying material from the glacier, that material will tend to be very well sorted. So as we examine our data in the form of our mini soil profile models, see if you can find evidence of glacial sediment. Is that glacial sediment sorted, or is it more random? And how do you know that it's glacial sediment? Okay, let's go take a look, and if you have any questions, let me know.